Hi everyone, welcome to the sixth help session of the course E220. Today we are going to solve three problems. Let's start with problem number one. In this problem, we've been asked to determine the power supplied by this dependent source. Here, the dependent source here is voltage dependent current source. It is a current source and it depends on voltage Vx. So in order to compute the power supplied by this dependent source, we have to calculate the voltage across this voltage source, and then for current supplied by this dependent source, we need to compute Vx. So let's start by naming the node. We have named node 1 and 2, and then let's assume the voltage across this dependent source with polarity shown here, plus, minus, and Vs be the voltage across this voltage source. Now let's start by applying KVL in the loop. This loop, if we apply KVL in the loop 1 x 2 to 1 in this loop, then we can compute Vs. Let's move in, let's say, any one direction. Let's move in this direction, counterclockwise direction. Then this will be, let's take the sign of the starting. So it will be minus 20, minus 10, plus Vs equals to 0. So this will give Vs equals to 30. Now let's now in order to compute this Vx, we need to we can see that we cannot apply KCL directly in any individual node. So we have to assume super node, and the super node here consists of 1, x, and node 2, because since there are voltage source present between these two nodes and even these two nodes, so we have to consider this as super node. So when applying KCL at this super node consisting of nodes 1, x, and 2, we have to neglect all the elements between these nodes. We have to neglect this 20 volt, we have to neglect this 10 volt source, and we have to neglect even this current source, because these are present between two nodes, right? So while applying KCL at these three supernodes, we have to consider only current through this branch, and this branch. So this 4 ampere is outgoing current, and let's assume current through 10 ohm branch as well as 2 ohm branch as outgoing currents. If we do so, outgoing current V1 by 2 flowing through here, and Vx by 10, and this also 4 is also outgoing current. So it will be equal to incoming current, that is 0. So after for the simplification, we get equation 1. And if we see node 1 and x, we can apply in node 1 and x, we can see that x is connected to the positive terminal of the battery and voltage source, and node 1 is connected to the negative terminal. So we can write Vx minus 1 equals 20. So if we solve this equation 1 and 2, we get value of Vx and V1. We don't need V1. Currently we only need Vx. So now if we let's again see here. Here we got Vs as positive and its polarity is plus minus as shown here in the figure, and the current flows from positive to negative. So if in any circuit element current is flowing from positive to negative inside the element, then in that case that particular circuit element will be consuming power, right? So in this case this element is consuming power. So if we want to calculate power supplied, then it will be negative of this current and voltage Vs, and current is 0.1 Vx, so it will be negative. So we can get finally 30 watts. Let's see problem number 2. In problem number 2, we have to use mesh analysis, and we have to put the equation in matrix form and solve it using Cramer's rule. Let's start by applying KVL in mesh 1. If we see here in mesh 1, there is only one resistor and one voltage source, right? So current is coming out of the negative terminal voltage source. So we're putting in right hand side minus 18, and for this current through 8 ohm resistor, we write 8 I1 minus I2, right? This 8 ohm resistor is between two meshes, I1 and I2. So current through this will be when you are applying KVL in mesh 1, we consider its current as I1 minus I2. And since the voltage is coming from a negative terminal, we're writing minus 18. After further simplification, we get this equation 1. let's apply KVL at mesh 2. In mesh 2, we can see that there is a voltage source, single voltage source, and two resistors. 40 ohm resistor is in outer branch, so it's not in common branch between two meshes. So for 14 ohm resistor, voltage drop is 14 into I2, and for 8 ohm resistor, voltage drop will be 8 I2 minus I1. And here for this voltage source, we can see that current is coming out of negative terminal, right? We are considering clockwise directional current. So since current is coming out of negative terminal, we are equating with minus 32. So if you see, we're equating minus 32 and these two. Now, after further simplification, we get this equation. Now, let's write these two equations in matrix form. In matrix form, there's the coefficients of I1 and I2 are 4 and minus 4. And for this equation, minus 4 and 11. And right hand side terms are minus 9 and minus 16. So here, now we will be using Cramer's rule. If we use Cramer's rule, then we have to calculate first of all delta. The delta here is the determinant of this term, coefficients matrix term, and its determinant will be given by the product of this diagonal minus this. Okay, so 11 into 4, 44 minus 16 equals to 28. Now, after that, we'll compute delta 1. Delta 1 will be given by the determinant of this coefficient matrix if we replace this first column by a right hand side matrix. Okay, so we'll bring this first column by this right hand side. Other elements are same. In this way, we can calculate determine delta 1. And for delta 2, we'll be replacing this coefficient matrix, second column of coefficient matrix, by this RHS term. And we got delta 2 equals to minus 100. Now, I1 will be given by delta 1 by delta, which will be minus 5.82 amperes. And I2 will be given by delta 2 by delta, which equals to minus 3.57. In this way, we can apply Cramer's rule to calculate current I1 and I2. Now let's see the problem number 3. Here we need to find V1 in this circuit, and we are not allowed to use mesh analysis or nodal analysis. We can simply apply circuit reduction and source transformation. And the given thing is, we have been given I is equals to 2.5, and then we have to compute V naught. So in order to reduce the circuit, first of all, let's see. We are here we can see that current source is in parallel with this resistor, right? So in this particular condition, we cannot apply any resistance circuit reduction rule, right? These two resistors are neither in series nor in parallel. So to make these resistors in series, we are converting this current source with parallel resistor into voltage source with series resistor. So if you are converting this current source with parallel resistor into voltage source with series resistor, then V will be given by I into R. I into R means 2 into 16 will usually be 32 volt. And in this way, we can convert this current source with parallel resistor into voltage source with series resistor. And even for this part of circuit, if we see this part of circuit, this 6 and 3 are in parallel, and overall this overall resistor will be in series with 10 ohm. So the equivalent resistance will be given by 6 parallel 3 plus 10, which will be 6 parallel 3 equals to 2 plus 10 equals 12. So here also we can reduce this circuit and make it 12. Now we'll get this circuit, right? Where we've reduced these three elements into 12, and here 2 ohm resistor with 2 ampere current source with 16 ohm resistor, we've converted into 16 ohm resistor in series with the voltage source, right? And the polarity of the voltage source will be like this, minus plus, and this arrow, if you see this arrow. Now we can see that 16 ohm and 20 ohm, this is series circuit, right? Now it will be easy here for us to compute. Now let's reduce the circuit, this portion. In order to reduce this portion, we can see that these two voltage source as well as these resistors are in series. But regarding voltage source, if you see, this starts from minus and ends in plus, but this starts from plus and ends in minus, right? If you see clockwise direction, if you move in clockwise direction, so these two voltages are opposite in direction, but in series, so they'll subtract each other, So total voltage will be given by 32 minus 8 equals 24. And for total equivalent resistor this will be added, 16 plus 20 equals to 36. And for this portion of circuit, we can see that current source is in parallel with resistor. So if we convert this into a series, voltage source in series with resistor, then we can add with this resistor, right? So we'll also convert this into a voltage source with value V equals to IR equals to 36, 3 into 12. So this will give this portion here, 36 and 12. And here, this 36 resistor, ohm resistor, and 24 volt voltage source. Now, if we see this portion of circuit, we can simplify this. These are in series. But first of all, let's focus on this portion. Here, you can see that 36 and 24 are in series. Now, this 36 and 12 volt, 36 and 12 ohm resistors, these are neither in series nor in parallel. So when we convert this voltage source with series resistor into current source with parallel resistor, then these two elements will be in parallel. So in order to do that, we'll convert this into current source with series resistor, and the value of current source will be I equals to V by R equals to 24 by 36 equals 2 by 3. Now we get this thing, okay? This we have converted into current source with parallel resistor 36. Now we can see that 36 and 12 are in series. Now the series 36 and 12 are in parallel. Now the parallel combination of 36 and 12 will result in 9, and the resulting are equivalent and current source in parallel. We can convert it into voltage source with series resistor. Why? Because finally, if we convert this into series component, then we'll give a simple circuit, right? So V equals to IR, I equals to 2 by 3, and R equals to 9. So 2 by 3 times 9 will give 6. Now, finally, we got a very simple circuit, series circuit. Since we got a series circuit, we can add up the resistors here and add up the voltage sources. If we do so, then we can simply apply Ohm's law, V equals to IR. So you need to find this, let's say I equals to V by R. V total will be, if you see here, minus plus, minus plus, minus plus, right? All resistors have same polarity, so they have to be added. V0 plus 6 plus 36. Resistor are also added, 9, 12, 7, which will give 28. And we are also given current I, right? I is 2.5 ampere. So if we write 2.5 equals to V0 plus 42 by V0 plus 42 by 28. So after further simplification, we got V0 equals to 28 volts. Thank you. This is all for this help session. See you later. Bye.